Dave Whiteley. I'm Technical Director of Envisage UK Ltd, and I'd like to take this opportunity to show you our add-in for Autodesk Inventor called iTools. We've written a number of routines over the years and put them together into this package, and I'd like to go through them with you now. Okay, the first one is iframe. It's a frame generator membering numbering system. We've got an iframe settings in the Envisage apps toolbar or ribbon. This allows you to configure the numbering scheme. In this case, it will take the assembly name, put a dash after it, and then a number of digits. It all depends on the number of the asterisks that you add after the comma there. In this case, it'll add up to 99 numbers. So what we do is we take our frame generator model. It's been saved, obviously, because you can't then run the frame generator without saving. We turn all the options off at the bottom of the dialog box. We don't need those. And we go ahead and add our frame members to the frame generator assembly. You notice this is called frame 1, this assembly, so the idea is that all the members will be called frame 1-001-002, etc. The first thing it does is it actually renames the frame and the skeleton files in the frame generator assembly. This enables you to have unique file names in your project or vault. All these begin with frame 1 in this case, and dash frame or dash skeleton for the file names. We go ahead and populate the frame generator model. As you can see from the browser, it then goes ahead and numbers the frame members according to the numbering scheme that we've chosen. Okay, the next one is 3D PDF out. This uses two free programs that you need to download first. One's called MeshLab, the other one's called Mictex. These are free to download and use, and this routine then uses these programs to create a PDF file from the model that we've got on the Inventor screen. The PDF file is produced as a grey 3D model. Unfortunately, we can't do colour, and it's also quite a basic 3D PDF file in that we can't choose or look at the separate parts in this assembly in the PDF file, but it does give you a 3D PDF output. The PDF file can be opened up in any of the PDF viewers. Okay, the next one is Ole Surfer. The reason why this was written initially was people were having problems with bad or sick Ole references in their part files and drawings. So we wrote the Ole Surfer routine. It basically looks at the model that you've got open and looks to see if there are any Microsoft Ole objects in this model. In this case there is. There's a bitmap that's has a missing reference. It's a sick reference, so we can go ahead and click on the delete column and then mark it to say yes, okay, and that will then delete that sick reference from the model. No more problem with sick Ole references in your drawings and part files. Next one is insert. This enables you to insert multiple references or instances of fasteners, anything that's got a round face on it basically. In this case we've got a fastener here, we've got some holes of the same diameter in our plate. We just select a circular reference on the fastener, the hole that it's going into, a face, and it'll add an instance of that fastener to all holes of the same diameter on that face. The next one is iDraw. This is one of our favourites. This will actually produce automatic 2D drawings. So here we've got an assembly opened in Inventor. We run the iDraw command. We select a drawing template. We then have a dialog box which looks at the drawing template. It knows its first angle projection in this case. We can also, if we want to, go and reload a different drawing template should we wish from the dialog. The part selection is available to us. We can either select single parts or all the parts. We've got options for automatic rotation of base view, center lines, retrieve dimensions, ignore purchased parts, add a flat pattern for sheet metal, shade the ISO view. We can also choose which layout we want on our drawing. If we select all parts, it will find all the unique parts in the assembly. If you go to select parts, then you can go and singularly select the parts from the model. We'll select all the parts in this assembly, click on OK, and that will go ahead and produce 2D drawings of all the parts in this instance, all the parts in this assembly, creating what it will do is it will add automatic center lines if you've asked for them. It will retrieve dimensions if you've asked for them. If it does retrieve dimensions, it will center the dimension text. It will also do an arrange of the dimensions around the model, and it will automatically scale as best it can to fit the drawing sheet. And if you've asked it to rotate the base view, it will, to keep the base view horizontal in relationship to your drawing template. The drawings are all left open for you to go ahead and process the drawings in any way you wish, and then obviously save them to whatever folder you require. As you can see in this instance, center lines have been added, all the drawings have been, the dimensions have been added, centered and arranged correctly around the views. And there you are, there's iDraw. Randomize was written because customers are being sent third-party models from suppliers, and once they imported them, they tended to get hundreds, if not thousands, of just grey parts in the assembly. So we wrote randomize to randomly colour all the parts in an assembly or a multi-body model, and it just enables you to visually see the difference between the parts in your assembly. It's added as a design view called randomize, which you can delete should you wish, so it doesn't do any damage to the model or the assembly itself. 3D pipe was written for a customer who wanted to bring in, they were modelling 3D brake pipes for cars, where you're basically given a number of points. So we can input tabulated data here where we've got the bend radius, the XYZ value of the nodes of the 3D pipe run. This tends to be given on drawings where they've just shown you a pipe run through a car, and they just give you a table of data that you need to use to actually create your pipe run. We then put the internal diameter in and the external diameter. Click on OK, and that produces the 3D pipe run. STL import. This is written to enable us to import ASCII or binary STL files into Inventor. It tells you what it's actually reading. It then brings in a preview, tells you how many facets are actually in this model. And then if you click on OK, it will actually read this into the construction folder as surfaces. And then you can use tools such as Sculpt to take this surface model and convert it to a solid. And there you are, solid model. iViews, this was written because a lot of people or a lot of customers are now producing parametric models, and of course if you've got a drawing of a parametric model, the drawing views scales keep moving. So what we did is we wrote something called iViews, which enables you to add viewports to your drawing and constrain the view to that particular viewport. So you add views as normal. You then go to iViews from the Envisage Apps ribbon. Set up the iView. You can make it update on save should you wish. And then you select a view. When you draw an imaginary rectangle around the viewport, or to create the viewport that you actually want that view to fit to, we'll do the same for the isometric view. Draw a viewport, you want it to fit inside that imaginary viewport. Then click on Update Sheet, and it actually then updates the views to fit that sheet or all sheets on your drawing. You go back to the model and change the size of the model. Back to the drawing. Update the sheets, and the drawing view is resized to fit those imaginary viewports. So we haven't got a problem now of viewports or views resizing on a drawing sheet and moving outside the drawing sheet. You can edit the sketch to change the viewport should you wish. There we are, iViews, automatic scaling viewports in Inventor drawings. In this instance, I want to go through the grid lines for Inventor application, which will create structural steel grid lines for an Inventor model. So I've got a model of a building here, and I want to add a grid line. If we go to the Envisage Apps ribbon, we can then go to the grid lines command, and in here we can give the grid lines part file a file name. This will be a reference in the bill of materials, so it doesn't actually get added to the BOM. And in the X direction we can create a number of labels, and the offset between these labels in meters, and likewise in the Y direction we can create some labels. You can call these whatever you like, and again offset between the planes in meters. The height is purely the height of the work planes as they're created in the 3D model, and the grid extents, again in meters, is the extension of the work planes, which will help the display in the 2D drawing. If we click on OK, that will then create this part with the grid, which we can turn on and off as you'd expect in Inventor. And then if I go to the drawing views and we go to our Envisage Apps ribbon again, we've got grid labels and remove grids commands. If I go to grid labels and select a view, that will actually create the grid lines in that view, and again grid labels, select this view, and so on. And then when we've created the grids, these can be edited, grip edited in the drawing should you wish, and also in the assembly. If we go back to the grid itself and rename the work planes, so if I call this 1.A for instance, you've got to keep the plus in front. That's to enable us to recognize these planes in the drawing routine. So as long as you keep the plus in front, everything works fine. I'll call this 1A. If I go back to the drawing grid, go to grid labels again, select the view, that'll then update the views, and as you can see the grid labels change accordingly to the work planes in the assembly. Just let this refresh, and there's your grid lines for your building. So thank you very much. That's iTools. From Envisage UK, there's our details, contact details on the page. Also available from us, we've got auto save for Inventor and automatic part numbering for Inventor. The automatic part numbering enables you to number your drawing file, your model files in Inventor to numbering schemes. These numbering schemes can be part based or assembly based, and it works in such things as all the design assistants. It works with mirror, multi-body parts. So the automatic part numbering works throughout Inventor. So thank you very much.